Good evening, all. Good evening. You're welcome to Tutorials with Formatante the Schoolboy. Today we are going to take a look at our chemistry. We'll do a review of our chemistry assignment. Number 1 says pure solvents are obtained by A. Evaporation, B. Extraction, C. Condensation, D. Distillation. What's the answer? A. Evaporation. Wow. Evaporation. Elimeri. What's the answer?
I'll go with
A. Evaporation. Evaporation. D. Distillation. Evaporation, distillation. What's that? Let me see your work. Let me see your work first. You don't know that we'll review chemistry today.
I didn't know the assignments he gave us last.
You are not there?
We did a lot of assignments of us.
I don't understand.
I was doing the assignments he gave us on Saturday.
This one that was given on Friday and come.
I didn't know I forgot.
You forgot it?
But I did it, sir.
So what's the answer? Majority said evaporation. So if you heat it and the solvent evaporates, so how will you collect the solvent that has evaporated? How will you do it? Tell us, how do you intend to get pure solvent from evaporation? How do you intend to do it? Anyway, the answer is what? Distillation. The answer is what? Distillation. By the time we do distillation process, it has some element of evaporation and some element of what? Condensation. Are we together? Because if you get the impure liquid, maybe a mixture of water and alcohol or something, as you heat it, when you get to each of them, when they get to a particular temperature, water will do what? They will do what? Separate, right? You have you have a condenser, lady condenser, that you pass through the vapor, and you get it will condense, and it will come down and say distillates the liquid form. So there's a combination of what? Evaporation, because you need to evaporate from the surface, true of us. But now you guide it now with your apparatus, so you can collect it. You also, there's an element of condensation there, because as they go up, as the vapor go up, it will condense. When they pass through the condenser, it will condense and appear as what? Distillate, which is what? Liquid, true of us. So the answer is actually what? Distillation. Are we together? Good. Number 2, we'll still do it anyway. Number 2. The following compounds are given with their corresponding boiling points. The compounds are IV, V, and their respective boiling points are 14 degrees Celsius, 24 degrees Celsius, 0 degrees Celsius, 120 degrees Celsius, -2 degrees Celsius. From the above information, indicate which of the following is correct. What's the answer? C. 3 of the compounds are gaseous at 20 degrees Celsius. Why do you say C? Explain. What's the reason for choosing C?
3 of
What are those those compounds from the question? Mm-hmm. Mm-hmm. And what? And V. You say that the reason why you chose C is because the three compounds, their boiling point are what? Are not up to what? That's why they will be gaseous at 20 degrees Celsius. That's why they will be gaseous at 20 degrees Celsius. Because their boiling point is not up to what? 20 degrees. Who agree with him? Who agree with him? Nobody. Who disagree with him? Huh? Who disagrees with him? That means all of you don't know it now. Why did you choose B? Huh? Huh? Well, yes. Why do you choose B? Huh? Because of what? So is that why they will be gaseous at 20 degrees Celsius? Do you actually understand? Did you actually understand what I taught you when I taught you a boiling point? What did we define as boiling point? Huh? Temperature that did what? At which what?
Equal to atmospheric pressure.
It's equal to what? Atmospheric pressure. I agree with you. The temperature. Now, see what it means. Actually, Izu got the answer, but the reason is not that. It's not the reason. Izu didn't get the reason. He got the answer, but he did not get the reason. Now, we are told that the five of them, they have their boiling point is 14 degrees Celsius, 24 degrees Celsius, 0 degrees Celsius, 120 degrees Celsius, and minus 2 degrees Celsius. If you watch the options we are seeing there is at 20 degrees Celsius, at 20 degrees Celsius. Now, if a substance has a boiling point at 14 degrees Celsius, remember the implication of boiling is that as the thing is boiling, vapor is vaporizing. I hope you know. Are we there? Now, what it means that at boiling points, anything above the boiling point, it will boil. Anything above the boiling point, it will turn to what? Gas. That's the meaning. Now, for the one that has a boiling point of 14 degrees Celsius, the implication is this: anything above 14 degrees Celsius, let's say 15 degrees Celsius, the thing is already what? Gas. True or false? So that compound that has a boiling point of 14 degrees Celsius, at 20 degrees Celsius is what? It's a gas. True or false? True or false? Who didn't understand what I said now? What does it say about the boiling points?
Is it on this question?
Generally, what does we discuss about the boiling points?
The boiling point is temperature at which the temperature is equivalent to the atmosphere.
It's something. So what is the implication in terms of the state of matter of that substance? What happened to this liquid? It will turn to what? Good. If you boil it more, anything above the boiling point, right? Now you are told that the boiling point of the first one, I, is 14 degrees Celsius. So if boiling point of I is 14 degrees Celsius, at 20 degrees Celsius, will I still be liquid? What will you be by that time? Gas. True or false? Now, so I will be gaseous at what? 20 degrees Celsius. Look at II. II has a boiling point of 24 degrees Celsius. At 20 degrees Celsius, will it be liquid or gas? It will still be liquid because it will be preparing to boil, right? Now, what of I that has boiling point of 0 degrees Celsius? At 20 degrees Celsius, what will happen to it? So that means I will be gaseous at what? 20 degrees Celsius, right? Now let's look at IV. Boiling point of IV is 120 degrees Celsius. At 20 degrees Celsius, what will happen to IV? It will just remain where it is and gradually the molecules will be gradually gaining what? Kinetic energy, true or false? So it will still be liquid, right? Now what of V minus 2 degrees Celsius? In the words of Chibuzo, what happened to it? It has finished. Chibuzo said that it has finished. So actually, I, and I is this, right? I is this one, right? And V will be gaseous at what? So the answer is what? C. 3 of the compounds are gaseous at what? 20 degrees Celsius. Is it clear? Is it clear? Good. Now, number 3 says mixture is different from a compound because A, the properties of a compound are those of its individual constituent, while those of a mixture differ from its constituent. B, a mixture is always homogeneous, while a compound is not. C, the constituents of a compound are chemically bound together, while those of a mixture are not. D, a mixture can be presented by a chemical formula, while a compound cannot. Chiwe, what's the answer? C is what? A mixture, C is what? The constituents of a compound are chemically bound together. Why those of a mixture are not? Who supports her answer? Who? You support her. Who else? Is it Chiku? Who else? Who else? Ellie Mary. Did you support her? Or do you have a contrary answer? A says what? The properties of a compound are those of its individual constituents, while those of a mixture differ from its constituents. Chibuzo, where do you stand? C. Where do you stand? Michael? C. So why do you say A? And Mary, you are the only voice, one voice in the wilderness. So tell us, why did you say A?
The mixture is heterogeneous in nature, which means that it's not only made up of only one constituent, and many constituents can make up a mixture. While a compound is homogeneous, that's why I just feel this.
Okay, now let me explain. Okay, you were not here when you discussed it. Actually, I like the way you reason, but it's not the answer. A mixture can be homogeneous, it can be heterogeneous. A mixture can be, if you get water and sugar, mix water and sugar you use at home to drink pap, put it in water, the sugar will dissolve. You won't even see the sugar again in the water. Everything will become one phase. It's homogeneous. It's not homogeneous. It will form a clear solution. It's homogeneous. But get a powder or water or sand and pour in water, it will be cloudy. Right? If you pour the powder you rub on your face in water and shake it, it will be cloudy. That mixture is not homogeneous because it's not a solution. It's not homogeneous. If you allow it, powder will settle down. True of us, they will separate to tell you that it has two faces, so it's not homogeneous. The same thing if you get sand and pour in water and shake it, the sand will fly. But once you keep it on for some time, it will cool down. it will cool. It will settle down on the bottom of the cup or something, and the two layers will separate. So it's not a homogeneous mixture. So a mixture can be homogeneous. It can also be what? Heterogeneous. But a compound is always what? Homogeneous. So a compound, from the answer you picked, that the properties of a compound are those of its individual constituent is not true. Because when individual constituents of a compound come together, they are bonded by a chemical bond to form an entirely new substance. Remember, a compound is entirely new substance from its component elements or constituents. Because let's take water, hydrogen, and oxygen. Hydrogen has its characteristics. Oxygen has its own characteristics. If they come together and establish a bond to form water, water has entirely different characteristics from what? Oxygen and what? And hydrogen. And you cannot separate them using physical, this thing we are saying, distillation, filtration. You can't separate hydrogen and oxygen in water using those physical processes. You cannot work. True of us. So that's why the A you chose is wrong. B says a mixture is always homogeneous. It's still wrong. A mixture can be homogeneous or heterogeneous, depending. C, the constituents of a compound are chemically bound together. Why those of a mixture are not? Yes, you can separate a mixture because they are not bound. The constituents are not bound together in a chemical bond. So you can easily separate them, either using distillation, using different separation techniques. So the answer is C. This says a mixture can be represented by a chemical bond. It's a lie. So the answer is what? C. Is it clear now? Now, number 4. A difference between chemical and physical change is that in a chemical change, A, oxygen is consumed. Or must be consumed? Consumed. Consumed. Come here. It should be here. Consumed. Okay. A, oxygen is consumed. B, heat is supplied. C, a reversible process. D, a new substance is formed. Chibuzo, what's the answer? D is what? A new substance is formed. No need asking you. We just discussed it here. A chemical change. A new substance is what? Formed. Okay? A compound is formed from a chemical change. True of us? True of us? True of us? Good. So no need asking you the reason. We have dealt with that question for over and over. So I don't think it's a new thing to us. Now, number 5. Number 5 says a mixture of a common salt, ammonium chloride, and barium sulfate can be best separated by A, addition of water followed by filtration, then sublimation. B, addition of water followed by sublimation, then filtration. C, sublimation followed by addition of water, then filtration. D, fractional distillation. Fractional distillation. What's the answer? Eliminate. B. Why do you say B? Explain.
B is addition of water followed by sublimation, then filtration. And we have a mixture of common salt, ammonium chloride, and barium sulfate.
Okay.
So now we have salt, which is sodium chloride,
Okay.
NaCl. When you now kind of add water, then sublimation is when a substance in a liquid phase directly changes to gas immediately. So when you kind of change it to gas by heating it.
Who can answer that question? You tried that, but you missed it. So who can answer that question? Izoya, let's hear from you. Oh, so why do you say A?
if you add water to the mixture,
Mm-hmm.
then those that can dissolve in it will dissolve. Those that cannot dissolve in it will be filtered.
Thank you. Thank you, lawyer. Yeah.
Cannot be
Huh?
many.
Hope you're scoring yourself. Huh? I hope you're scoring yourself. Score yourself now. If anyone with correct, you check your. If you got it, you score yourself. You fail it, score yourself, and make the correction, please. No idea. Michael, lawyer.
C. But I don't know why.
Michael says C, but he doesn't know why. Michael has gone online and copied the answer. He said C.
You.
It's okay. At least you tried. Chingwe.
I got it.
You don't do it. I'll start flogging you, Chingwe. Oh yeah. Come see.
I don't know the reason, but I think
Okay, you and Michael did something.
I think it's B.
Okay, you think it's D? Hey, yeah. You is even the word self.
I said B.
B.
Yeah.
B is not the answer. Only Michael got it, but he doesn't know how he got it. Why C is the answer? Now let me explain. Let me start from A. Listen carefully. So, common salt, which is sodium chloride, is soluble in water. Are we together? It's soluble in water, as in very soluble in water. Ammonium chloride is also very what? Soluble in what? It's soluble in water. But barium is not soluble in what? Water. Now, barium will form, it will not dissolve. Are you there? Passing very rapidly, it will not dissolve. You may need to go and start heating but it won't dissolve. Now, it says addition of water followed by filtration, then sublimation. Now, watch out. If you add water, the whole thing will be muggled up. Sodium chloride and ammonium chloride will dissolve in this solution, right? Then barium will not dissolve. Barium sulfate will not dissolve. If you filter, sodium chloride and the ammonium chloride will pass through. So how will you not separate sodium chloride and ammonium distillate? So make sure you go and start heating. If you heat two of them, water, you know that ammonium chloride is already in liquid form. Am I communicating? You have issues heating it. You have issues heating it at that point in time. Are we there? Now, if you choose B, addition of water followed by sublimation, then filtration. The same thing that happened in A will happen in B. If you add water, ammonium chloride and sodium chloride will dissolve. Then everything will be muggled up in that liquid, in that mixture, and you start heating. How will you heat it? How will ammonium chloride sublimate out of it? Everything is already. If it's in solid form, you can easily do what? Sublimate. Are we together? So water has touched it at this point. You have issues here. Now C, look at C. Everything is still in solid form. If you heat it, just apply small heat, sodium chloride will remain. Sodium chloride will remain what? Stable. Barium chloride will remain what? Stable. Ammonium chloride will do what? Leave. Okay. Once you do you prepare your this thing very well. Ammonium chloride will leave and go and they form and they get deposited on top of what the apparatus you use in the heating. It will go on top and do what? Form there. It will sublimate and form solid there. You can easily do what? Remove it. Are we together? Now, what is remaining there is what? Barium sulfate and what? And what? Sodium chloride. So if you add water, Sodium chloride will do what? Dissolve. Barium sulfate will not do what? Dissolve. You can now filter. Sodium chloride will enter the filtrate. Barium sulfate will remain as what? As what? Residue. Then you can get your sodium chloride. You can heat it. Water will do what? Go. You get your what? Your what? Salt. You have separated the three of them. True of us? Good. Look at the fractional distillation. This one is different. This one has no business with this ones. We are doing fractional distillation is used mainly for crude oil extraction and the purification of crude oil into different fractions. Okay, employing their differences in boiling point. Okay, but this is solid. This one will work mainly with what? No, but we will see discuss it. So the most appropriate answer here is what? C. Yeah? Okay, he said you are not listening. He said you are not listening. Thank you very much. Her mind wasn't there when I said it. I said that in the apparatus you use, that's how you design it. You can design it to collect once you heat it, it will leave solid. It will leave the mixture, the solid mixture, sublimate and leave and go and deposit on top. You can open that thing and collect your what? Ammonium what? Chloride. That's what happened. Okay? Then you can now add water to dissolve the sodium chloride and filter. Sodium chloride will go with water, but the barium sulfate will remain as what? Residue. You cannot get the solution that contains what? The filtrate that contains sodium chloride. Then heat it to evaporate the water. The water will go. Then sodium chloride will remain. We have separated the three of them. True of us. So C is the most appropriate one. Option there. So who got it? Only you not get it. I hope you know. You can say you got it. So that's the review of answer. Any question? All right. So if you see this a question in exam or anyway, at least you can apply this knowledge and answer it. True or false? Good. In your chemistry qualitative analysis, you employ this idea there to hope you know. Are you aware? Good. All right. We will stop here for today. Thank you very much. See you next time. Okay, I'm surprised you say that I did not explain this. Now I told you something. The first thing I said is that this distillation will still treat it as what? Separation techniques. But I explained something. I told you that Izuchukwu said that number one is what? Evaporation. And it seems somebody else said condensation. Who said condensation? Someone said Someone said condensation here.
Nobody said.
Who? Mark, you say C. You say C. You say C. You said C. Did you say C? You say C now. You say C. When you say C now, and C is what? Condensation. You say C. You. But the first I heard from him was C.
Okay, yeah.
What are you talking about now? What are you talking about? The first thing he said was C. I heard it right. See, whenever I'm dealing with you, be careful because anything you say, I recorded it, but you won't even know. You said C, and that what led me to try to explain and say I was like, okay, that I understand where they are coming from. Izui is not completely wrong, as being wrong. Mike is also. I now say that this distillation has some element of evaporation and some element of what? Condensation. And I'll say, okay, that remember that if you have with this thing we explained last about evaporation. Like now, see now, see sodium chloride solution now. If you heat it, the water will do what? Evaporate. But the problem is that in evaporation, your intention is not to gather. In evaporation, what you need, what you want to gather is not what left, what leaves. True of us is the solid you are interested in. True of us. That's why you will not say evaporation. Now, because if you are interested in the water that leaves the sodium chloride solution as what? Gas. Because it will leave as gas, right? As gas. If you are interested in it, you need something that will condense it. It's not true. It's not true. To get what? Liquid. If you are doing that, you are distilling. True of us, you are distilling. That's why by the time we treat distillation, there's what is called Leydig condenser. They connect it with mixture of two liquid you want to separate. Once you heat it, if one get to its boiling point, it will boil and leave as gas and pass through the pipe and pass through the condenser, which will now cool it down. It will become a liquid, and you collect it as a what? Distillate. So it will evaporate to leave the surface. It's not true, and pass through the condenser and become a liquid. Is that not two things? Evaporation and what? Condensation. So this process of coming up as gas and you condensing it to turn to liquid as a distillate is what is called what? Distillation. That's why I say that distillation has some element of what? Evaporation and what? Condensation. Because it must evaporate from the mixture before you can collect it back as what? Liquid. Does it make sense? So that's what I explain here. And these three human beings, these four human beings here, open their mouth and said, I didn't explain it. What is all this? Thank God who is here. You see, they denied me that I didn't explain it. You should thank you. God bless you. You were with them. All right, but is it clear now? Is it clear? We'll still do the distillation as a topic under separation. In fact, that's the next topic we will do in chemistry. I just expose us to this, so we'll prepare our mind, have the idea before we now go into them. Is it clear now? All right. So let's stop here for real. I hope that there have no quick question again on this, because we are entering into another thing now. All right. God bless you.